Hi everyone, here is a setup for today's experiment. Today's experiment involves titration. Titration is a simple chemical analysis where you need a burette, an Erlenmeyer flask, and also a pH meter. In this experiment, we are going to titrate a triprotic acid against a 0.1 molar sodium hydroxide. As we are adding each 1 ml of sodium hydroxide from the burette, a pH changes. We record that pH. In most cases, obviously, it goes from low acidic pH to a higher pH. At each equivalence point, there is a significant change in pH. So as we are adding the sodium hydroxide, each proton would be neutralized stepwise at a point where endpoint 1 would show the neutralization of proton 1, 2, and 3 respectively. So after collecting each pH value against the volume of sodium hydroxide added, we're gonna plot a graph which has a pH versus volume of sodium hydroxide added. This is an electrode, pH electrode, and just measure the initial acidic pH. Obviously that's very acidic. I'll just say pH. It's right now it's showing about 1.71, so I'll wait until it stabilizes. So that's the initial acidic solution for our titration. It is 25 ml and it's a triprotic acid. So the initial pH will be measured. Once we have the initial pH measured, we will titrate it against 0.1 molar sodium hydroxide. So the pH is about now stabilizing at 1.6. Now slowly the pH is going up to now 2.09. We are added about 10 ml of sodium hydroxide. At this point the pH is 2.09. At 30 ml we are at 2.82 pH. That's 30 ml of sodium hydroxide added, and the pH is 2.82. I'll continue adding. So I added 1 ml more. Now the pH has jumped to 2.93. It looks like it's some of the equivalence point, I believe. This is 3.11. It's the highest change I saw so far. This also looks like a rapid change. At 34 ml of sodium hydroxide, we see a pH of 3.92. So it's slowly going up. This looks like the highest jump. It should be an equivalence point, because from 3.92 we are jumping to about 5.35. So it definitely shows a point where there is a proton exchange. That means there is an equivalence point of sodium hydroxide has been used. So now the titration is progressing well, and I have added already 44 ml of sodium hydroxide, and the pH is 6.75. Now we are going slowly to the basic region of the titration curve, because we are more than pH 7, which is 7.58 at 54 ml of sodium hydroxide. So we are in the basic region of the titration curve. You can see here now the biggest jump, since the earlier one was 8.43. After addition of the last 1 ml, we have jumped to 9.74. It's almost flat now because it has reached where most of the protons are deprotonated, and we might be well past the third proton has been already deprotonated. Almost the curve has plateaued and the pH is changing very slowly. That means it's reached the plateau of the curve. Now it's 11.43. I'll keep on adding some more volume, where the point that K of water is being used for the calculation, because most of your solution now is purely a basic solution where the equilibrium is mostly hydroxide ion is mostly in the solution. Therefore, the application in the calculation would involve the K of the acid and K of the base, and also the K of water to calculate all of the equilibrium concentrations you need to know. So at 70 ml, the final pH is 11.56. So that's the end of our titration. Next step is to plot the pH against the volume of sodium hydroxide added. And from the curve, we're going to analyze the pKa1, pKa2, pKa3, and also equivalence point 1, equivalence point 2, and equivalence point 3.